right, good morning, everyone. Welcome to my talk, Safer Apps from Docker Security Building Blocks. My name is Riyaz Faizullabhoy. I'm a security engineer at Docker, and I'm very excited to give this talk to you today. So, without further ado, I'd like to just show you this small terminal snippet. For those familiar with Docker, you may have seen this before. For those who are not, it's maybe the first time, and let me explain what's going on. So you have Docker stack deploy, and with Docker, with one command, you can deploy an entire application stack, right? Front end, back end, database, memory storage, all configured, all fully customizable, and very easy. But the reason why I'm talking to you today is that because even though it's easy, it doesn't mean that it's simple. And really, there are a lot of pieces under the hood that are working to make this command magic and make your applications run like magic. And in this talk today, we're going to look at all of these pieces that are necessary to do this, but not just do this, but do it securely. And so with that, I'd like to draw an analogy to one of my favorite games, Tetris. In Tetris, it's a simple game. You have these blocks, which are actually called tetrominoes. I learned that earlier, like a domino, but tetromino. And you're given them one by one, and you place them onto the floor, onto the board, and try to make full lines. And infrastructure security is actually a lot like Tetris, because in Tetris, when you make a mistake, you have these holes. These holes start to build up until you get to the top of the screen, and you lose the game. But in infrastructure security, you can think of these holes like vulnerabilities. If pieces of your infrastructure don't line up and don't talk to each other, don't integrate securely, you end up with these vulnerabilities, and you'll lose the game of infrastructure security. So with that, I'd like to introduce a few of our own tetrominoes that we've been working on at Docker. And in this talk, 7 of them. All 7 tetrominoes are open source projects that you can find today on GitHub. And I like to call them out individually and tell you about how they work under the hood and how they work together. So with that, today I'll be talking to you about Infrakit, LinuxKit, RunC, Containerd, Docker, Notary, and SwarmKit. So with that, let's get to our first tetromino, Infrakit, which gives us infrastructure-independent machine management. What I mean by this is that with Infrakit, you can manage machines, VMs, bare metal, across any platform you wish. So AWS, Azure, cloud, even on your local host, on your Linux or OS X platform of choice. And it lets you spin up and manage the lifecycle of the virtual machine. So not only can you say, I want N virtual machines, but I want them to stay healthy, and I want them to stay alive and to work together. And all this is entirely JSON-based. So you have a declarative system for specifying your infrastructure as code. So you say exactly what you want in the JSON file, you run an Infrakit commit, and Infrakit will make it happen, magically. Well, not magically, but under the hood, all the details happen. And what's really magical about Infrakit is that if the state ever deviates, say you wanted 5 machines, and one, for some reason, tries to goes unhealthy or something, Infrakit will do its best to keep the state constant and to bring back the node if it can and reconcile the state. Likewise, what's also very interesting with Infrakit is that you can update the JSON. Say there's a new version of an OS, or you want to include a patch. You can edit your JSON, bump the version number, Infrakit commit, and Infrakit will know that the new state needs to be accounted for and will update your machines for you. And with this, I want to introduce a very important security property that you can achieve with Infrakit and systems like Infrakit, which is reverse uptime. So how many here are familiar with the concept of uptime? I think it's pretty common. So with uptime, right, you talk about, oh, my system has been, generally people use that as a kind of a proxy for something being healthy, right? My system's been up for days, weeks, months, years. But really, you should be thinking about, instead of counting up, for security, you should be thinking about counting down. And after a certain amount of time, a machine should be recommissioned. And there are 3 very important reasons why you should consider this. So firstly, you can have OS drift. So you may provision a number of machines. They're all healthy. But as you want to update and tinker with different settings and different configurations, the state of each individual machine may drift from one another and may cause unexpected downtime. Say you updated one machine but not another, or something happened, some error in your update scripts. So with Infrakit and with reverse uptime, by constantly refreshing machines to weeks, months, you can be more sure that the exact configuration is running across your infrastructure. Secondly, you want to make sure that you have all the latest security kernel updates and other infrastructure code updates. And by constantly refreshing machines, again, you have an opportunity to pick up recent patches and patch quickly. And lastly, if you're always refreshing machines, say an attacker somehow gets a backdoor into one of your applications and compromises one of your hosts, their life gets a lot harder if you're constantly refreshing machines and blowing away any persistence. Once an attacker's in, they can do whatever they want, but if you remove the machine, they have to go back and attack again, and at that point, you may have already patched. So by removing persistence and by taking old machines and redeploying with a new golden image, you have the chance to update that golden image for all the security updates, for any configuration updates, but also kick out any attackers that may have found a persistence via backdoor. And Infrakit makes this easy with rolling deploys. So you can, with Infrakit, configure, say, hey, I want to have a rolling deploy with my new golden image that my security team, releases team, infrastructure team has vetted and approved. And Infrakit will be able to remove the old machines and create new ones with rolling deploy to minimize any disruption, so you don't have any downtime. That's Infrakit. I'd like to now move on to our next tetromino, LinuxKit, which is an OS builder for your containers. Not an OS itself. It's not like Ubuntu or Debian or Fedora, but it's like a builder. And to kind of show you what that means, this is how you specify an OS with LinuxKit. It's completely YAML-based, and whatever is in the YAML is exactly what will go into LinuxKit-based OS, and nothing more. So in this example, I've kept the YAML file. I have a kernel from version 49.54. I gave it a command line. I have an init view of processes. In particular, it actually sets up containers, RunC and containerd to run containers in the system. On boot, I say give me networking, so DHCP. I ask for a shell with Getty. Note that if I don't put in Getty, I don't get a shell. And that's exactly what goes into my LinuxKit OS, nothing more. So really what you should be thinking about is when you're running OSs in your infrastructure, a lot of the run-of-the-mill OSs, there are so many hundreds of binaries and systems, like services that are running on that system that you probably don't even need. And so why would you even consider having them lying around as extra attack surface for hackers to have fun with, when instead you can know exactly what's running in your infrastructure and know that nothing more is running. And so you can build an operating system in the least privileged sense, that exactly what you say you want in that operating system is shipped into your infrastructure. Kind of a fun fact as well is that for those who are familiar with Docker, you might notice that the images look like Docker images, and they actually are. So you can today take LinuxKit images from Docker Hub and create your own and share them around, which is quite nice. So one thing about LinuxKit to kind of further motivate why you want a minimal OS and minimal set of components, we took it a step further, and I mentioned that we have our own images. We have our own kernel image that we've kind of put together. You can use from Docker Hub, and really we took minimal as a guiding principle in that kernel as well. So with that, we have only recent kernels that have been configured with the best practices from the Kernel Self-Protection Project and many other experts in the field. We strive not to include any extra drivers or gunk that you don't need on a LinuxKit-based OS to run your applications and containers. And for those who are familiar with the Alpine Linux distribution, it's another Linux distribution that also takes a minimal approach as a guiding principle. And one really awesome thing that Alpine has done is they have a completely hardened user space toolchain where they've configured the best compiler flags. For background, Alpine uses Muscle, libc, and BusyBox. And really, we were big fans of what Alpine was doing in user space and have borrowed many of their packages for our own use, which is quite nice. Going a step further, not just being minimal, we also wanted LinuxKit to be immutable at the root file system level. So by making the root file system immutable, you can't, once you build that YAML exactly what you want, which includes any configuration, like important configuration in etc, we didn't want to give the attack surface of being able to update LinuxKit on the fly, or for attackers to modify with values. So with that, we have an immutable file system, which is quite nice. And I guess here, for more background, for those who are familiar with containers, this might ring a bell with container images. The best practice is to have consider a container as immutable. So running a container infrastructure, if you want to update it, you can simply recreate a new one with your updated system. And so with this, with LinuxKit, we took a very similar approach, considering the root file system to be mutable, and that if you want to build a new LinuxKit, you should have a new YAML file where you understand exactly what you're building, why you're building it, before shipping it. Also of note with LinuxKit, we've been working quite a lot with the upstream Linux community and future projects that are being experimented in the kernel hardened list and on the various security lists. I'd like to tell you about a few. So firstly, for those who are familiar with Linux security modules, if you've heard of AppArmor or SELinux, there's an exciting one that has a few patch sets already called Landlock. Landlock is quite interesting for LinuxKit in particular because Landlock makes use of a relatively recent kernel feature known as extended Berkeley packet filters. And kind of the TLDR for the Berkeley packet filters is that you can see every syscall, you can see all the interactions in the kernel, as well as a lot of context. So you can look into arguments in the kernel and look into exactly why the system call is being called. And this is really exciting because with Landlock, it takes this information and lets you write policies around it. So for example, don't allow writing on these inodes, or don't allow this type of network packet to go through. So we're really excited about how fine-grained that can be, and in particular, when you have a complex system with containers, for example, where you have all these Linux primitives meshing together in really interesting ways, Landlock provides a really, really, really promising way to make informed security decisions about what to allow and what to deny. Another project that we actually have in the LinuxKit kernels and user space for you to try is called WireGuard. WireGuard is a VPN. It's based off of, or rather it implements the noise protocol, which you may have seen is a very, very, very good piece of crypto that's been integrated into other systems as well. And WireGuard is very exciting because you have a fully featured VPN that's using modern cryptography from the noise protocol, and it's also only like 5,000 lines of code. So it's been well reviewed. Folks understand how it works, what the attack surface of it looks like. And so it's a well-reviewed project and also a very promising project for networking across your services and containers and across hosts. So we're very excited there. We're also working with a bunch of different partners on other projects such as okernel, which is a way of splitting the kernel into less privileged and more privileged parts, as well as we've been working with ARM support on LinuxKit, which has been very exciting, and trusted boot. And so one thing I want to note about LinuxKit is, for many of you it might be new, that I'm talking to you about it today, but it's actually been in use by thousands and millions of people already. So if you've been familiar with Docker for Mac, Docker for Windows, Docker for AWS, Azure, all these platforms are actually using LinuxKit under the hood. So with those projects, if you used them before, if you use Docker for Mac, you know that you have a nice GUI, and you don't even actually know that you're running a separate OS unless you really dig into the internals. And so you've been shipping LinuxKit with these platforms for quite a while, and I think along the way, it's really helped us understand what we could do in LinuxKit, how minimal we could get, and it really, I think, doubled down on our decisions. We were really excited about, look, the minimal OS with these configurations and with these things, it works, and folks are happy. And so we're really excited about that. And so in the future, look to more exciting things in LinuxKit happening and seeing it bubble up into Docker for Mac, Docker for Windows, as well as other projects. Other projects in the ecosystem have been using LinuxKit, and it's very exciting. So with that, I'd like to move on to our next domino, which is RunC. RunC is a lightweight universal container runtime. It's actually been donated to the OCI, so it's a standard. And for those who are familiar with containers and Docker, the way you should, if you're not familiar with RunC already, the way you should think about RunC is it handles all of the guts of how to set up a container. So really what a containers are from is containers are built on Linux primitives. So of note, you have namespaces, which give you isolation between different resources and kind of views of the world, and you have C groups. There are a few other things as well, but those are the big two. To give you an idea of what namespaces are, there are quite a few of them for PIDs, process IDs, mount, IPC, network. For example, in a PID namespace, you can only see the processes that are in your namespace. So if you've used a container before, you may know that when you run PS, you don't see the entire host's lists of services and processes. You see just the containers. And that's because the container is in a PID namespace. So those are namespaces. And RunC sets these up for you when you run a container with RunC. And C groups are really about restricting resources from the hosts and between other containers. So for example, you can have C groups for CPU, for memory, even for PIDs, if you'd like. And what you can do with C groups is you can say, look, this container A can run on CPU 1. You can say, like, it runs on CPU 1 and 2. You can say, this container runs with only up to half of the CPU, and this container runs with a third of the CPU, and so on and so forth. And so you can, with RunC, you can set up the namespaces to say, look, this container can only see this, and the C group to say this container can only use this. And so really, RunC is all about giving you the ability to create containers and to use these underlying Linux primitives for your containers and really set those up. And so with RunC, you can create containers, you can use the namespaces, use the C groups, really use that. But what our next piece is all about is once you create a container, there are a bunch of now extra things to think about. Like, if the container exits, what do I do? Is the container alive? Is it healthy? And that's really where you need a runtime supervisor for your containers. And so we have a project that we've spun out of Docker and is now donated to the CNCF called Containerd. And yeah, really what Containerd is all about is a supervisor. Is the container still running? Is it healthy? Did it exit? If it did exit, should I rerun it? Like, should I rerun it? Is that safe? And so Containerd is all about that. One really interesting security property I like to really point out with Containerd is when you pull an image. So how many folks here are familiar with like a Docker pull, like Alpine latest? Okay. So in Docker pull Alpine latest, you have an image name or an image repository like Alpine, and you have a tag. It's usually like a human readable name, like a version, or latest is a very popular one. Really, what's under the hood though, under the human readable tag, it points to a unique piece of content, and that content is specified by a digest. So an example here is I have Alpine at SHA-256, 29D234, blah, 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 blah. That's my digest. And what that digest is it's actually a content address that says, look for the image at the address SHA-292D, blah, 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 blah. And what's really exciting here is that on a pull by digest, is what this is, you actually get a hash tree where you have a top-level object called a manifest, which says, okay, here's my image, and here are all its pieces. And all the individual layers, all the individual pieces have their own digest. And the digests, if you take each individual layer and hash them all together, that hash is represented as the manifest, in the manifest hash. So once you have that single identifier, when you do Docker pull at SHA-256 hash, you're now going to an address, downloading the content, and you can verify when you download the content by hash that the hashes match. And in doing that, you've also implicitly verified that each of the layers that bubbled up in that single hash also match. So you have full integrity over all the layers and net in your full image. And so Containerd is really exciting because Containerd does this for you. It handles the pull by digest. It handles basically making every pull into a pull by digest, which is really awesome. It gives you this really nice security guarantee of the integrity of your images. And so with that, I'd like to talk about our next piece, which for those in the room is probably more familiar and takes parts of Containerd and RunC and other parts of pieces I've talked about so far, which is Docker. And Docker, the way you should think about Docker in the context of RunC and Containerd is that it coordinates with these two projects. And it does so in an opinionated way to create a secure by default container platform. So what do I mean by secure by default? What does Docker do? So there are a number of features that are on for you by default. So firstly, I mentioned with LinuxKit, Linux security module for landlock. Docker has default profiles for SELinux and AppArmor, which are existing Linux security modules that are included in most Linux distributions today. So out of the box, you have SELinux and AppArmor profiles. These profiles tell Docker you cannot touch these sensitive file paths like proc or sys. You cannot use these syscalls. You cannot use these capabilities. Here's your profile for what you can do. And really, out of the box, you have this access control that restricts file paths and permissions of all the containers that are run by Docker. On top of that, within Linux, I think most of us are familiar with root and non-root, but how many people here have heard of capabilities within Linux? Okay, a handful. So really, actually, what Linux does, has under the hood, is there's more to just root and non-root. There are actually capabilities that can give you an amount of permission in between. So there are about 40 such capabilities. You can think of it as capsysadmin is probably like the most well-known one, which gives you pretty much root. There are other ones for network, like can I bind a port? Can I send raw packets? And so there are about 40 of these capabilities. And out of the box, Docker has a whitelist of 13 that your containers can run with. So you have less than half the capabilities for your containers out of the box. Of course, if you want to tinker and add more capability, you're more than welcome to, and you can with the command line arguments or other configuration. But out of the box, you have that whitelist for you of less than half the capabilities. And then lastly, or not lastly, how many people here have heard of seccomp? Okay, we're getting into the kernel the kernel weeds. So seccomp is actually very similar again to landlock, what it's doing with syscall filtering with extended Berkeley packet filters. It uses a similar mechanism to sniff every syscall and allow you to make decisions on the syscall, so it's not as robust as the extended Berkeley packet filter. You can't inspect the arguments deeply, but you can basically say, look, for this syscall, deny it, allow it, etc. So out of the box, Docker will also ship with a seccomp profile, which has a whitelist of syscalls. So you drastically reduce the kernel attack surface for any containers that you spin up with Docker. And then lastly, I think for a lot of folks here who are running apps that don't need to change the file system, apps that are relatively stateless, one thing you can do with Docker, it's not default, but you can turn on, is you can have your containers be read-only. So like LinuxKit, where you can modify the file system, you can have your containers also be read-only so that you know exactly that the container is not, it's not drifting in configuration, it's not drifting in its state from what you intended it to be at runtime, or at ship time. And so with that, you can have, it's like -- read-only, and you can set your containers to be read-only when they're run with Docker. So out of the box, you get all of these essentially set up for you. Again, if you want to make them more restrictive, less restrictive, we have knobs. But this is out of the box, secure by default for your containers. So we talked a little bit about containers. We talked about running them. We talked about how they run with Linux. And I kind of talked a little bit about this with Containerd, but the next piece, the next tetromino that I want to talk about is really about trusted delivery for your containers. So how do we get our images or any other piece of content securely on our host in the first place so we can then run it? And so with that, I'd like to introduce Notary, which is another project that actually just got donated to CNCF, so really excited about that. That is really a state-of-the-art signing system project. And so for many folks here who are familiar with signing and GPG, you know that signing gives you integrity. Basically, did this thing change or not? It didn't change. And authenticity, who signed this, which key signed this, over any kind of content. And what Notary does is it takes signatures to provide a cryptographic name resolution. So it says, here's the name of my signature, or the name of the entry that I'm signing for. So an example might be like latest or v1, and here's the hash. And I'll create a signature over that. So for those who are trying to look at the slide, you're kind of looking at latest and stable and edge. These may look like Docker image tag names, and in fact, they are. And that Notary can be used for help us translating from Docker image names to secure hashes that Containerd can use. It could also be used, Notary can be used for any kind of content. So I joke that you can use Notary for cat videos if you really want to. There are a number of projects in the wild, such as Collide, that use Notary for OS query updates. There's even an interesting project from Cloudflare that uses Notary to securely get information for container identity by signing off on some content there. So Notary is really about cryptographic name resolution for any kind of content. And Notary really has a really interesting history, and the reason why it's general is that it comes from this spec called the Update Framework. And the Update Framework is a research project out of New York University, the School of Engineering. And before that, it actually came out of the Tor project. So for those who are familiar with Tor, Tor is a tool for anonymous browsing with the internet. And if you've heard of Tor before, you probably know that Tor is of interest to many high-profile attackers, is a way of putting it. And as you can imagine, if you can, as an attacker, if you can compromise the Tor updating system, you've made it big, right? You can compromise how Tor is getting updated, and you can put in your own code or like a backdoor into Tor. You basically have popped Tor. Tor is no longer anonymous. So the Tor folks said, yep, let's make a really, really good update system for Tor. And so they did that, and that project is called Fandy. And so Fandy really took signing and made it, a state-of-the-art framework. So you could understand not only like who signed this and has it changed, but also is it fresh? Like is it the content is it not like a really old Tor that may have a backdoor now? Like is it a fresh piece of software? It also lets you do more advanced things, such as threshold signing and being able to rotate keys pretty easily. But what you should take away from this is that from Tor, there was Fandy, this update system, and the folks at NYU were like, hey, this is really cool, this is really good, but we need to generalize it for more pieces of software. And so with that, you have the update framework, which exists on GitHub. Actually, it's open source, also in CNCF. And there's a living spec where you can read the spec. It's probably about like a 30-minute read if you want to check it out. It's not too scary to read. It's quite approachable. And it's really exciting because it takes the really, really advanced attacker model from lessons learned in Tor and generalizes that to be used across all pieces of software. And so Notary, what it really is Notary is an implementation of the update framework, which is why you can use Notary with many different pieces of software if you'd like. Of course, at Docker, we've used it extensively with Docker images, but you can use it with many pieces of software. And I mentioned briefly that because Notary uses the update framework, you can do many interesting things. And one thing I really want to point out, which is probably most relevant to folks in the room who are running infrastructure, is you can do threshold signing. So you can say, for this piece of software, for this image, sign it at each stage of my CI/CD pipeline. So for example, your devs release some code, they sign it, saying that they made this code. It then goes into the staging environment, development environment, and runs and passes some tests, and CI signs it. And then it goes to the security team that says, okay, are there any CVEs? Can we scan this? Any issues? No, let's sign it. And then deploy to production. And at production, you can say, only deploy code, only deploy containers, images, whatever, that have been signed off by security, CI, and dev. And so with Notary, this is possible. And one thing that's really exciting as well is that if at any stage someone loses their key, it's not an end-of-the-world event. So for those who have GPG keys, you know one of two things. One, if you've tried setting up subkeys and it's kind of difficult, so not many people have. And 2, if you lose your GPG key, that's it. You have to tell everyone else who trusted your GPG key, hey, sorry, I lost my key. Please revoke that one. Here's the new one, and update your web of trust. And so with Notary and actually the update framework, it has an intelligent way of being able to rotate keys by using a hierarchy of keys and an offline key to basically allow any authorized user, anyone who has a key in the system, to be able to rotate their key without changing your root of trust. And so losing a key is no longer an end-of-world event, which is really exciting. And so with that, we've been talking about running containers. We've talked about how to get the containers. We haven't talked about how to run many containers across a cluster, across hundreds, thousands of nodes. And so with that, I'd like to introduce our last tetromino, SwarmKit, a least privileged container orchestrator. And with SwarmKit, we took least privilege very seriously to the point that there's only one way for a node to be introduced to a Swarm cluster. And the only way to do that is securely. And so in order to join the cluster, you must provide a token that has different cryptographic properties in the token to join the cluster. So we'll go one by one through each of the pieces of this token. There are 4 parts. So the first part is probably the kind of the funniest part, but probably the most useful for everyone here is it's just a known prefix, so swarm token, so that if someone accidentally commits it to GitHub or it somehow gets in your logs, you can easily grep for a swarm token and find it and note that you need to rotate keys, or rotate tokens rather. So for usability and for your own auditing, you can just search for swarm token. Second piece is a token version, just in case token changes. I don't think it has yet so far. And now we get to the 2 interesting parts for crypto, which are the hash of the root CA and random secret. So for those who have used SSH before, the first time you log into a host, you get that scary message, right? Like warning, like this is the first time you're in this host with this IP. Are you sure you want to do this? Do you trust this? And you type in yes, and then you can get in. And so that's called trust on first use, right? The first time you have to basically either you have to trust it implicitly, or you have to go around that with like SSH and say yes, I want to trust this. And so with swarm tokens, we actually do is we seed this hash. And this hash is the hash of the root certificate authority in the cluster. So the first time the node is talking to that certificate authority, it can self-compute the hash, and it doesn't have to ask you, are you sure you want to do this, or do you know who this is? Because the token knows. The token has information. And then the second part is a random secret, so that the nodes, so that you can't basically spoof the token, and that the manager knows this is a legit token. I should let this node join our cluster. And once you join the cluster, what's really interesting is that you actually get a cryptographic node identity. And what I mean by this is that the node gets a certificate, an X509 certificate, which you can use for TLS. For those who have been using TLS before, you're probably familiar with these. But in the certificate is an individual identifier for the node, which is in the CN. There's also a role saying that this node has this level of privilege. So basically, it can do tasks, or it can assign tasks, so worker or manager. And it also has the ID of the cluster it's joined, the Swarm ID. And the reason why I say this is cryptographic node identity is that you cannot spoof this because it's signed by the private key of the root, the root CA in the cluster. So no 2 nodes can have the same ID in this case, or you can't have another node try to impersonate one node because it needs to have the valid certificate and its own key material. And on top of this, there's constant rotation of these certificates handled by the cluster. And you can bring it down to 1 hour. So for those who have rotated certs before, know it's a pain. In Swarm, it's automatic. And so for those, like I kind of alluded to, once you have certificates, you now can use the certificates to talk with TLS, HTTPS, basically, for those who use TLS under the hood. And so we have mutual TLS for all cluster communications between the nodes. So what that means is that all the cluster communications, all the administrative sending down of tasks and figuring out the state, it's all encrypted, it's all authorized, it's all authenticated. So no one can sniff the network and try to change packets or sniff the network and understand what's happening unless they're actually validly joined the swarm with a token. And so you have encrypted control plane, And you also, as I mentioned earlier, since you have the role of the node embedded in the certificate, no node can impersonate or try to escalate privilege to another node. So for example, a worker cannot escalate privilege to a manager because its certificate doesn't have manager in it. And it can't forge a certificate because it can't sign with the root private key. So it has been locked in as a worker. And now once you have the secure channel communication, you can send down tasks, configurations in a secure way. But we also, in SwarmKit, took a lot of care for secrets. So for secrets, I mean database passwords, API keys, anything really that you want to remain private. And the way that this really, I think of many of the features in Swarm, this is really probably the most exciting for your applications to be safer, because now your database passwords, your other API keys can be securely distributed and stored. And so the way that this works is that by using mutual TLS, we know which node is which, and we also know which nodes are running what, and therefore what they need or what they don't need. So for example, if my red worker here is running my database, but my green node is not, I only need to send the database key down to the red node. And so with SwarmKit only sends down secrets to the nodes that need them, and when it does, it exposes it as a file that's actually stored in memory. And so it's super easy to integrate with your applications because you're just reading from a file, but then also as a security measure, once your container or a task is done, we can actually remove the secret, and the secret is never written to disk. So even once the container is gone, the task is gone, you can't get the secret back. Like the secret is tied to the work. And so this allows your applications to be more secure and to use secrets in a secure way. So you don't have to, please do not commit secrets to GitHub and do anything like that. Please use SwarmKit. And lastly, I've talked a lot about the root CA and the root key, and it's, as you can imagine, very important. And so I think one thing that sets SwarmKit apart from many systems, and for many security people in the room, I think this will be exciting, is you can actually, with SwarmKit, transparently rotate the root key material. And the reason why this is really exciting is for many people here who have whiteboarded on security things, I know this has happened many times with me, and ultimately, oftentimes at least, the security system boils down to root of trust, like a single key or like a single point that is your root of trust. And for many people, when you're threat modeling, you try to protect the root of trust, obviously, but once the root of trust is compromised, many people are just like, all right, we've been popped, we're done, nothing we can do, shrug, right? But really in SwarmKit, we realized that that was not enough. We could go a step further. We had the infrastructure to do better. And so what we did is we allowed a mechanism to securely rotate the root of trust in case of any compromise. So let me just walk through how it works briefly. So you have the swarm, we have a manager node and 3 worker nodes, and they currently trust the blue root CA, the blue key material. So maybe someday you decide, hey, let's rotate. So the way it works is the first step is you add the red root of trust to every node. So now they trust both blue and red. You actually renew that so that you have both trust in blue and red at this point. So you force the rotation to trust red at this point, but you're saying still trust blue. So you have a cert chain that includes both red and blue at this point. And then lastly, once all nodes you've determined that all nodes have updated to trust both red and blue, then you can remove blue. So immediately before this point, we didn't remove blue because there's a possibility that as you distribute a system, as you're updating, you need to make sure that all nodes are actually updated before you pull away the root of trust, because then they can't communicate over the control plane, because you can only communicate over mutual TLS. So lastly, the last step is once you determine you're ready, you then remove the blue. So really exciting. With SwarmKit, you can rotate that root of trust, and even in the face of a root key potential compromise, you have a way out. So I've introduced many pieces, and I've kind of talked briefly about how different pieces come together, but I think really where it gets really exciting is when you bring the pieces together, both within the trauma nodes that I've mentioned here, but also for trauma nodes that you may have in your infrastructure or other projects in the ecosystem. I think there's some really exciting integration. So let's maybe walk through a few and go back to Tetris. So first, we can use Notary and Docker together for image name resolution. So I mentioned earlier you could have Notary give you from tag to digest, and then Docker with containerd can use digest to layers and manifest. And what this gives you is cryptographically verified image pulls. Right? When you pull from any registry with, it's called Docker Content Trust is the official name of the integration, you're actually using Notary and all the goodness of the update framework to say, is this thing fresh? Is it up to date? I mean, is it what I wanted? And is the right person signed off on it? And so you can, regardless of cloud or CDN, you have a cryptographically verified pull for Docker images. Similarly, you can also use Notary with LinuxKit. Because I mentioned earlier, LinuxKit, we actually use many Docker images to ship around and distribute and build parts of the system. And so you actually have, once you build a LinuxKit system, every component can be pulled down with a Notary resolution. So you have a cryptographically verified build that exactly what you wanted to build in that YAML file is exactly your artifact that comes out after the build that you're then going to run your infrastructure. So moving on to another integration, we talked a little bit about mutual TLS and Swarm. And really, for Docker containers, you get all the same benefits of authorized, authenticated, encrypted delivery of resources for containers, configs. And we talked a bunch about secrets, but really, for configs and images, you get the same protections from mutual TLS from man-in-the-middle attackers. Man-in-the-middle attackers cannot inject bad configurations, they cannot sniff the network, and so your configurations and images are safe. And to get that Swarm in the first place, so you can run your containers on, Infrakit integrates really nicely with Swarm. Because with Infrakit, you can actually automate the dance of Swarm token for certificate. So you first receive the root CA from the manager, check that the root CA matches the hash in your token as a worker. You then send the token. The manager checks that it's legit. And also, you give it a CSR, certificate signing request, say, I want a certificate to join the cluster. And then lastly, you get back the signed certificate so you can talk with mutual TLS across the Swarm and you join securely. And so with Infrakit, you can automate and manage the secure node cluster introduction. In addition, I think I want to talk about a little bit about LinuxKit and Docker and how they work together. So I mentioned earlier that we use LinuxKit to build the OS for Docker for Mac, Docker for Windows. And I alluded to this earlier, but with LinuxKit, you really get a hardened configuration for Docker. So Docker itself actually runs in a containerd and RunC container with Docker for Mac and Docker for Windows. And so what we can do is we can actually finely tune exactly which capabilities Docker runs with, exactly what profile Docker runs with, how it's run, how it's pulled down from our registry with a secure image pull. And we have a hardened configuration both of Docker, but of course, with all the goodness of the kernel configuration and other pieces of the system, a hardened configuration for the entire OS. OK, so let's get a little more exciting here. Let's go with 3 pieces. So what can we do with Infrakit and Notary and LinuxKit? And so I think this really gets to some of the possibilities with using a newer kernel and using some of the more exciting pieces of infrastructure in the ecosystem and upstream Linux, is you can actually use these components together to get a cryptographically verified boot. And so what I mean by this is that there's this feature called dmverity that's upstream in Linux that essentially, if I was to summarize it, says, similar to how in Docker we have a hash for the layers of an image, you can say with dmverity, I have a hash for the hashes of block storage in my OS. So you have a single kind of a top of the tree hash. So you can imagine that we have Infrakit is a really nice way of spinning up VMs, so for LinuxKit based OS. But Notary is also a really great way to get hashes because we have that cryptographic name resolution from human readable name to cryptographic digest. So we can use Notary to securely sign in dmverity hashes. Notary can securely give that information to Infrakit, which will do all the signature verification and check this is the right signature. which can then use that hash to integrate with Verity on LinuxKit-based OS. So this is really exciting, kind of forward-looking way of using multiple of these components together for cryptographically verified boot, which would be really awesome. So another 3 pieces we can put together, and RunC, Containerd, and Docker. Well, this is probably what you're familiar with Docker itself, what we ship. And really what you get is a secure by default container execution. We talked about DAppArmor, SELinux, seccomp, cryptographic hash for pulls, namespace isolation, C groups, resources limitation. And so you get that all in a nice secure by default package. So let's get a little more exciting. What if we take Containerd, RunC, Docker, SwarmKit, and Notary? Well, now you have a full container platform where you can run containers across many nodes. And you have a secure by default container platform. And then if you want to add Infrakit and LinuxKit to the mix, you have RunC, Containerd, Docker, SwarmKit, Notary, Infrakit, LinuxKit. You now have a secure by default container infrastructure. Right? You have Infrakit spinning up LinuxKit-based OSs, which then you can use for your Docker, SwarmKit, Notary platform. So in this talk, we talked about Infrakit, LinuxKit, RunC, Containerd, Docker, Notary, and SwarmKit. And bringing these pieces all together is how we build a secure substrate for safer apps. And you put it all together, you get the Moby whale. So thank you very much. Sure. I have time for questions. Yeah.
Question about Docker secrets.
Sure.
Or using Docker swarms. Say we use a slightly more old-fashioned way of injecting secrets into containers, currently using environment variables. Can you elaborate on the consequences of doing so?
Sure. So the question for those who didn't hear is, what are the consequences of using environment variables for secrets in containers? Yeah. So there are quite a few, and I'll kind of summarize briefly. But environment variables are they're not as tied to the environment as you may think. It's quite easy to poke around and proc in other places and to children processes to actually view the environment variables. Many folks too. I mean, I hope this is not the case, but it's more common than you may think that people dump environment variables when debugging into logs, into other places. And so, of course, and then going further, the environment variables are not encrypted when you have them. And so you're risking a lot of exposure with environment variables. So I get that it's super usable. I know with Swarm Secrets, we deliberately used files because we figure that any framework or application probably knows how to read a file or any language. But yeah, be careful with environment variables.
So basically, we have to consider that it's available from anything that sits on that host.
Okay. Yeah, we can talk more offline as well about the exact setup. I'm happy to help. So, cool. Other questions? Yeah.
Yeah, you talked about SwarmKit.
Yes.
You have a secure secret distribution. Is it possible to use SwarmKit as a private secrets repository and to store other secrets other than the ones purely used for Swarm nodes distribution?
Yeah. So the question was, can you use SwarmKit as a general secrets storage system? So I think the way you should think about SwarmKit secrets is that it's really aimed at delivery to tasks within the swarm as opposed to storage. And so I think one ongoing effort within SwarmKit is actually to integrate with external secret storage systems like Vault and Kiwiz. And so I'd recommend those two are pretty. I think there's another one. I think Console. I forget the name. It's from Lyft, I think. But there's Kiwiz, Vault, a few others that are really about storage of secrets. If you want to use Swarm, so in theory, you could run with SwarmKit. You don't have to run containers. You can run generalized tasks. So in theory, if you wanted to use SwarmKit secrets to deliver secrets, you could do that. So up to you. I mean, if you want to have nodes in the swarm and then expose the secrets on the file system as a temp fest, like that would work in theory. So, yep. Okay. Other question? Yeah.
At the start, you talked about landlord and the VPN.
Yep.
Is that already used, or what's the roadmap for that?
Sure. So the question was, I talked about Landlock and WireGuard, the VPN. So the question is, what's the roadmap? Is it already used? So I'll talk about WireGuard first. WireGuard is actually, we've included it in the kernel and user space for LinuxKit, so you can use it today. I don't have usage numbers offhand, but that's there. It's also being tracked in various kernel communities. I think Jason Donenfeld, who's the maintainer, has been very active in trying to get development going. On the Landlock front, we have patches within kind of this, like we have this project subdirectory in the repo where you can, it's kind of like a playground, basically if you want to try Landlock, you can. We have all the patches there. Mikhail Salaun, who is the maintainer of Landlock, I think he's on patch 7th or something patch set. He has a roadmap. I can't recall it off the top of my head, but he's definitely on a roadmap to get that upstream. Both of them are. It's really exciting. Yep. Okay. Other questions? All right. Well, thank you very much for coming, and I'll see you around.